Value of unknown charge. Value of unknown charge placed at the midpoint. Placed at the midpoint of the line joining two equal and like charges. Value of unknown charge placed at the midpoint of the line joining two equal and like charges. In the diagram, we have two equal and like charges. Q1 and Q2 are the two equal and like charges which are placed at the point A and B. R is the distance between the two like and equal charges. C is a point. C is the midpoint of the line AB joining Q1 and Q2. Unknown charge Q3 is equal Q is placed at the midpoint C. Let an unknown charge Q3 equal Q be placed at the midpoint C between the two equal and like charges Q1 equal Q and Q2 equal Q, which are placed at the points A and B. And we have to find the value of unknown charge at equilibrium. At equilibrium, which charge? At equilibrium, the force experienced by which charge is zero. At equilibrium, the force experienced by any one of the known charge is zero. That means either Q1 or Q2. Force experienced by the known charge either Q1 and Q2 will be zero. Here we can denote two electrostatic forces experienced by Q1 due to Q2 and Q3. F12 is the electrostatic force of repulsion experienced by the charge Q1 due to the charge Q2. Similarly, there is another electrostatic force which is F13 experienced by the charge Q1 due to the unknown charge Q3. Here F12 and F13 are the electrostatic forces experienced by the known charge Q1 due to another known charge due to another known charge Q2 and unknown charge Q3. Another known charge Q2 and unknown charge Q3. Therefore, F12 equal 1 by 4 pi epsilon 0 Q2 Q1 divided by AB square is equal 1 by 4 pi epsilon 0 Q square by R square. It should be Q2 Q1 by BA square, not AB square. And this force F12 acts away with respect to the charge Q2 and from the point A. This force F12 acts away with respect to the charge Q2 and from the point A. Similarly, F13 is equal Q3 Q1 divided by CA square. In this case, for F12 it should be Q2 Q1 divided by BA square, and for F13 it should be 1 by 4 pi epsilon 0 Q3 Q1 divided by CA square equal 1 by 4 pi epsilon 0 Q capital Q small q divided by R by 2 whole square. Therefore, F13 equal 1 by 4 pi epsilon 0 4 capital Q small q divided by R square. F13 is the electrostatic force experienced by the charge Q1 which acts away with respect to the unknown charge Q3 and from the same point A. Therefore, net force experienced by the charge Q1 is F1, which is equal to F12 plus F13. F1 is equal to F12 plus F13. Therefore, F1 is equal 1 by 4 pi epsilon 0 Q square divided by R square, and Q by R square is taken common under bracket small q plus 4q. small q plus 4q. F1 equal 1 by 4 pi epsilon 0 q by r square small q by small q plus 4q, which is equation 1. And this is the net force experienced by the charge q1. At equilibrium, this net force F1 is equal to 0. Therefore, 1 by 4 pi epsilon 0 q by r square under brackets small q plus 4q is equal 0. Therefore, capital Q is equal to minus q by 4. Capital Q is equal minus q by 4, which is the expression or value of unknown charge placed at the midpoint of two equal and like charges at equilibrium. Capital Q is equal to minus small q by 4, which is the value of unknown charge, placed at the midpoint between two equal and like charges at equilibrium. This is the expression of unknown charge at equilibrium.